Reporting services expressions support all the usual programming language operators, including those that support arithmetic, comparison, and concatenation operations, as well as those that support the more esoteric bit operations. You can find a categorized list of operators in the expression editor. So I'll go ahead and open up the editor again for this Ship To text box. And I'll come down here to Operators, and there you have the set of categories. So there's various arithmetic operators. So there's the power operator, multiplication, divide, two different kinds of division, modulus, addition, subtraction, so forth. Rich comparisons. There's concatenation. Now remember this is Visual Basic. It uses Visual Basic syntax. So there's two concatenation operators. And I'll come back to those in just a moment. Then there's logical bitwise, the usual AND, NOT, OR, XOR, and also OR else, as well as bit shifting. Okay, now concatenation. This might be the only slightly odd thing. All the other operators are pretty standard for programming languages, although the symbol used may vary a little bit between languages. But in Visual Basic, you can use either a plus or an ampersand for string concatenation. Essentially what it's doing is it's overloading the plus operator for concatenation. And you can see that concatenation operator in use. This is building a big string of all of the different pieces of the set of address fields, and so it has to concatenate together the address on the first line, checks to see if the second street address line has anything, and then concatenates on the city, the state and province, the postal code, and the country region, and so forth. But the statement just as easily could have been written using pluses instead of ampersands. And in fact, you can mix and match them. So for example, I could change this to a plus, and that one to a plus, and this one to a plus. And the net effect, the calculated value, that string that's built based on this expression, is going to be the exact same. Now, I really strongly advise you that you use the ampersand operator for all concatenation operations. Because the plus is overloaded, it won't always be obvious whether you intend a concatenation or an addition operation, particularly if either of the operands is numeric. Don't let reporting services choose for you. Tell it what you want it to do by using the correct operator. If you truly want string concatenation, use the ampersand for string concatenation. Okay, so this is nothing special about Visual Basic. You can get into those data type issues in any programming language. Okay, another thing I want to point out is that the version of Visual Basic that's used with reporting services, and again, this is the reporting services in both SQL Server 2012 and 2014, it no longer requires a line continuation character, which is an underscore, in most situations. And the key there is that as long as the language compiler can tell that a statement continues on another line, you don't need to use that underscore. Okay, so in this particular case, it can tell that there is more to this expression that is coming, and so it doesn't require the line continuation. So just be aware, though, you may get into a situation where you have a red squiggly for a reason that you can't figure out. You may look to see if it's definitely certain, unambiguous, that the next line of code continues the same statement. Okay, so in that case, you just need to add an underscore to the end of the incomplete lines, separated by a space from the statement fragment with no trailing space. So if I wanted to do that here, see I have a space, and then I actually went beyond it, and I could put in an underscore, and that will tell the report that what follows is part of the remaining expression. Another one of the major building blocks of expressions in reporting services is the large collection of built-in functions. Collectively, these functions give you direct access to information about a report and its environment, as well as to facilitate calculations that you might need to do in order to maximize the value of a report to its users. As with most development platforms, a large part of learning to use reporting services effectively is to learn what's already there and built in, so you never need to waste time reinventing the wheel. Particularly since Microsoft has a pretty good track record at making these kinds of features as efficient as they can. So rather than writing your own, most of the time using the built-in function is going to perform much better. There are times where you need to test for some condition as part of a calculation. One use of such a test is to modify the display of a data field based on something about the data, some characteristic of the data. So here in this company orders report, it displays the unit price discount field. So that's that field right there. This is the detail row of the report, and so this is information about the individual order. Most records in the report dataset have 0% for this field's value. And if you display the numeric value, it's hard for the user's eye to see which items have non-zero values, because they have to scan down the list and see 0.00, 0.0000, and until they finally get one that is non-zero. It just makes it harder to find that information. So what this report does is it checks the value of that field and displays 2 hyphens for 0 values and the percentage value for non-zero values. And so if I go into the expression editor, you can see how I implemented that. So it's using this immediate if function. This is something built into Visual Basic that takes a Boolean expression as the first value there, and it checks to see if this value is greater than 0. Now, this test happens to work because I happen to know that the data within the table that this is being pulled from within the database has all non-null values. So the value for each row in the table for this field is going to be a 0 or a positive number. There's not any null values. If there were null values, I would need to expand this test a little bit to account for null values. Okay, so it checks to see if this is true. So if it's greater than 0, it's going to display that unit price discount value. Otherwise, if it's 0, which means that this expression here is false, then it's going to display 2 dashes. So what the expression is doing is it's looking at the value of that field for this row in the data set and then changing what's displayed based on that value. All right, I'll cancel out of that and preview the report. And as you can see here, most of the values in that column are 2 hyphens, which means that the discount is 0. But now it makes it very easy to find these non-zero values. And if I scroll down further, you can see that they just stick out dramatically. I've gone to the second page of the report, none on that page. And there's a couple of fairly large discounts. All right, go back over to design. I want to take another look at this ship to expression, because this uses the immediate if as well. What's going on here is that, once again, I know the data within the table, and I know that there's always a value for address line 1. So I'm going to always include that value. But there isn't always a value for address line 2. So I'm using immediate if to compare that to nothing. This is essentially checking to see if the address line 2 value is null. And this is the Visual Basic syntax, checking to see if it's nothing. Okay, if it is nothing, then it's just going to concatenate an empty string, which essentially means do nothing. But if it isn't nothing, so there is some value there, then it's going to concatenate on a comma and a space, and then the value of that field. Okay, now another option for performing this kind of operation, some sort of choosing sort of operation, is the switch function. That's useful for performing conditional tests. And what it does is it takes multiple pairs of parameters. One's a condition followed by a value, then another condition and a value, then another condition and a value, for as many of those pairs as you'd like. And the idea is that if the first condition for the first pair is true, then switch returns that first value, the second value of that pair. If condition 2, the second condition, is true, then it returns the second value. If the third condition is true, then it returns the third value. So the first one of those conditions that returns true, it's going to return the corresponding value. And again, you can include as many condition value pairs as you like within the function call. All right, so this report uses that function here within this field right here. Because what I want to do is highlight an order's total due amount. If the amount's less than $10,000, no highlighting, it's just white background, it just displays normally. But if the amount is $10,000 but less than $100,000, I want to make the background blue because this is a fairly substantial customer. And then if the amount is $100,000 or greater, I want to make the background red because that's an extremely important customer. We want to make sure that they get excellent service and so forth. So I can select that box and right-click on it and select Expression. And actually, I'm changing the background color. So here I need to go into Properties. And I still have the Properties box displayed in alphabetical order. So there you can see part of the expression. But I need to go into the expression editor to really be able to see the whole thing. All right, so the first pair of parameters is this. So if the total due value is less than $10,000, I'm going to assign the string white to this background color property. Here's the second pair of parameters. So if the value is less than 100,000, I'm going to display a blue background. Now keep in mind that it's going to evaluate these pairs of conditions until it finds a true value. So if the order value, the total due, is say $5,000, this is going to be satisfied. It's going to set the color to white, it's done processing, and goes on with whatever the next step is. But if this turns out not to be true, the value is greater than 10,000, it'll move on to the next one. If this turns out to be true, it sets the color as blue. But if that also is false, then it continues on to the next one, and it checks to see if the total value due is greater than 100,000, and then assigns it a value of red. So that's how it's setting the background color. Now the highlighting actually requires an expression for a second property, and that's the font color. The problem is that I'm going to have a value of either a white background or a blue background, a fairly dark blue, or a red background. The default color of the font for this report is black, and so I'm going to have fairly low contrast, particularly with that blue color. So the other thing I do is for that text box here, I'm going to go over here into the color property, which is actually the font color, and I have an expression for that as well. Here, if the value is less than $10,000, I'm going to keep the font black. Otherwise, if it's greater than 10,000, in other words, it's going to have a background of color of blue or red, I'm going to set the font to white. Okay, so that shows how you can use a couple properties in concert and expressions for both of them in order to get some interesting effects. So if I preview the report again and go over here, you can see that this is greater than $100,000, so the background color is red and the font is white. Scroll down here a bit. Go to the next page. So here's an amount that the total due is less than $10,000, so it's not highlighted at all, it just has the white background. But here's one that is between $10,000 and $100,000, and so it displays in that blue background. And you can continue scrolling down the report and see all the total due values. There's another one that's $39,000 and another one that's under $10,000. All right, then there's also a choose function that selects a specified value from a list of arguments. And it just uses syntax where the first parameter is the index that you want to use, and then a set of expressions that will be returned based on that index value. I didn't use the choose function in this report, but it's another option for doing the same basic sorts of things that you can do with switch and immediate if functions. At this point, I've shown you just a few of the built-in functions that are available to you from reporting services. You can make use of lots of other Visual Basic functions. And here are a few of some of the other commonly used functions. And this is just a sample. I'll have a few more to show you as well. But keep in mind, too, that you also have access to a large number of .NET Framework classes. They're at your disposal, You just have to build them in and use them within the expressions. Okay, but what's built into reporting services is various string functions. So like left returns the leftmost character of a string. Mid returns a subset of characters from a string. Len gives you the length of a string. And inster returns a position of a substring within a string. So you have some reasonably robust set of string functions. Certainly more than you have within Transact SQL. And then there's some date and time, some very rich date and time functions, including month that returns the current month based on a date. It can be today's date, or it can be some date that you pass it. Maybe it's a field that you've read from the database. The month name returns the name of the month. And then you can also do date manipulation, such as date addition, that adds days, months, years, whatever, to a date. And then a few more. There's various aggregates, sum, average, count, min, and max. There's a lot of conversion functions, converting to a string, converting to an int, and so forth. So very rich support for converting between data type. And then there's a few reporting services specific. Like level returns the level in a nested hierarchy. Previous is real handy. It gives you the value for a field of the previous row within the data set. And so that makes it possible to do various comparisons on a row-by-row basis as the report is executing. And then you can do things like get the row number that returns the row number of that row within that data set. Last thing I want to talk about in this section is null handling. Bottom line is just that dealing with null values is a fact of life within SQL Server. And that assumes that your database makes use of them. Now you can test for the existence of a null value in reporting services with this kind of comparison. Field is nothing. And nothing is a Visual Basic keyword, and it's equivalent to just null within Transact SQL. For example, earlier I showed you the expression that builds the ship to address string, and I show you that again there. Within that immediate if function, the expression checks to see if the address line to field is null. Strictly speaking, the value of it is null. And then determines what to concatenate based on that comparison. And the result is a nicely constructed string that handles the case where the second address line is missing. And by the way, for text fields, you can also use the len of field equals 0 comparison to test for nulls, because the null value gets converted into an empty string. This isn't going to work with numeric fields, however, so you have to be careful how you use that you're not going to get an error because of data type sorts of issues. Now, normally, you don't need to worry about nulls in reporting services, because reporting services automatically casts null values into empty strings for text boxes. So most of the time, you don't need to explicitly test for null values. It is possible, however, to create an expression that employs a function that will return an error when a null value is encountered. In those kinds of situations, you're going to want to test for a null using isNothing. For example, the int function, which you can use to remove the fractional portion of a number, will return an error when you give it a null value. So you need to test if it's nothing before you pass that value to that function.